So we're basically done the linked list. We talk about how we can implement our own linked list, and we talk about how we're adding elements into the list, how we're removing element, and what is going to be the complexity of each of those basically methods or functionalities in the linked list. We also kind of talked about ArrayList before, the fact that the ArrayList also in the background using the fixed size array data structure, and it just make it like we always hear that the ArrayLists are dynamic. So we're gonna make our own ArrayList now today that it's actually also dynamic. So we want to see how we can make the fixed size array of Java to be a dynamic data structure. So that's why, again, we're going to call it MyArrayList. As usual, I'm going to start with having our, basically our class diagram for it. So I don't know if I can move this. So that's going to be our class. So as you remember, when we're talking about the ArrayList, there are two concepts basically we have here. Usually we only have the concepts of the size. Basically, that's the number of elements that we have in our list. That we store in the list. But when we're talking about the dynamic array list like this, we also have another concept, but that's basically the capacity. So the capacity is how much we really have a space in this array, basically, in this list. So when we're trying to make it like a dynamic, we want to make sure that we basically constantly have to compare the value of our size, so basically the number of elements that we have in the list, and we want to compare that value with the capacity of the list. So that way, we can basically make sure that we still have enough size or enough element space for the elements in the array. So immediately when we notice that this ratio of our size capacity gets very close to almost 90 or 100%, for example, then we're trying to now start increasing the size. So as you know, we can't really do anything unless we have this array that is a fixed size array data structure. So we need to tell them exactly what is going to be the capacity when we create this array. So in Java, in the specification of the ArrayList that they implement, that this is going to be, I believe, 11 or 10. That's the default capacity that they use. So immediately when you're creating your ArrayList, it's going to create an array of capacity 11, and then you're going to add 11 into your array. And at some point, because capacity and size are going to be very close to each other, it means we're almost getting close to be 100% full. So what is going to happen now is going to start resizing. And it's going to double size of this array. So now this array that started with capacity 11, now it's going to become, for example, 22. How this is going to happen, obviously, it's going to create a completely new fixed size array with with the double capacity, and it's going to start manual, or basically with the method in the background, copy element one by one into this new array in a different part of the memory. Because arrays, remember, is it's going to be back-to-back in the memory. So you need a block of memory exactly with the size that you want from the beginning. So if your capacity is done and you have no more space, you need to really copy everything to another block with a larger size. So what we're going to do today in our basically MyArrayList class that we're going to implement, we're going to create this capacity to be 4, so we can see how it's going to basically get large. And then we're going to implement a method that we're going to call it resize. So every time we're adding or removing element from this list, we're going to keep checking the ratio, capacity, and the size. And immediately when we get to the close to 100%, then we start double size of the array. Another thing that we're going to do, which is the actual implementation of array in Java is not going to do that, is that the shrinking basically, right? So we double size of the array, and we also automatically going to check the value of this ratio and the size, and whenever it gets to only 25%, that means like more than half of our array is completely, or half of our capacity is completely empty, then it's automatically going to shrink the basically array as well for us. So it's going to make it half. So but basically we have now two requirements here. First is that if the capacity is full 100%, we're going to reduce it to, or sorry, we're going to increase it to double, and whenever the capacity is only 25%, that means we have 75% empty, then we're going to reduce it to half, right? So that's going to be how we're going to implement it. But in the Java implementation, it's only going to increase the size, not going to shrink it. There's a method called trim to size. That is the one that you, as a client basically of MyArrayList, you can call it, and that is going to basically help you to reduce. And that what the trim to size is going to do is going to make the capacity and size exactly similar to each other. It's get rid of all the extra spaces that you have inside your array list. But again, we're not going to do that. We're just trying to play with it and basically implement our own array list. So we're going to have this requirement that every time that the value of the ratio of size and capacity is 100%, and we're going to double size of the array, or double capacity basically of the array. And if the ratio is only 25%, then we're going to basically make the half, reduce the capacity to half. So this is how we're going to implement our resize method. So this is going to be our requirement to implementing our resize method. So also, and like in any data structure, when we have collection of data, we would like to add elements to it, remove elements from it. So we're going to follow the same thing we did inside our linked list, right? We're going to implement add element to the beginning, add element to the end, and so on. So we're going to have the same exact kind of method that we had in our linked list structure that we implemented. So that way we can compare them with each other. So as you remember, there's a trade-off of using each of them. So you have to know what is the application, what you really want to do, and then decide which data structure you're going to use, right? So what kind of data you have and what you really want to use, how you want to use the data, then based on that you decide that it's going to be useful to use ArrayList for it, or you want to use the linked list for it. So also I know that we have some students that joined online, and so basically, please, if you have any question, you can raise your hand here, or you can even text basically me, chat with me, so I can answer your questions as well. Okay, so back to our this is now here. We need to go back to our starting programming. So we're going to go back to our Eclipse application, and so this is our linked list and our test for the linked list. So we're now going to create our own class, and I'm going to call this class MyArrayList. So we just saw that it's gone basically, but that's a problem with this whiteboard in the recording session, that it's basically going to remove it every time I'm getting out of the whiteboard. I wish there was a way that we can save it. Anyway, so as we just explained, we're going to also kind of follow what we did in the for now in the linked list. So we're going to store elements inside a string. So all of our elements is string basically. So we're going to focus only on the string. So we're not going to have a generic type at this point. So I'm going to call this an array list. And then we already mentioned that we're going to have these concepts of capacity. And I'm going to have a default capacity as 4. So we can see, whenever we have to increase or decrease or the size, basically, or shrink or grow. And then we're also going to have this member that is going to be our size. So by default, the size is going to be 0, right? And we don't have anything stored in this array list. Also, we're going to basically have our constructor. In Java, when they're implementing the array list, we have like 3 constructors. You have a default constructor, again, as I said, that's going to use the default capacity 11. If you're using the constructor that collecting another array, so you can pass an array to it, so then it's going to use the size of the array, and it's going to create that capacity exactly. Or you can also call another constructor, the third constructor, that is going to keep the or get the capacity from you. So it's going to automatically override the capacity. So you already know that you're going to create an array list that, and it's going to, for example, need the capacity of 100 or 200 already from the beginning. So you just directly change the capacity and start it from that. That way you don't have to keep, because it's adding, extra resources when you're trying to keep resizing. You can imagine you have to create a different place in the memory, copy everything over there. So that can be a little bit expensive overhead. So if you already know from the beginning that you have more data to store, so you don't want to use a default capacity that is 11, right? So if you already know, so you're just calling that constructor. So here we're just going to create these 2 constructors, basically. One that is going to be the default constructor, basically no argument. And it's going to create this array list that we have here, this fixed list data structure that we have, and it's going to create basically one with the capacity of 4. So it's going to use this capacity that we have here as the value for creating this default array. Another one also, just to kind of following what the Java do, is going to get the capacity value from the user in case they want to override the default capacity, and then that way it's going to basically by default create that capacity for our array. So then this is similar to this, so it's going to use that.
Couldn't you just call this?
We could use this. I mean, we want to override the value of capacity because we're going to use that throughout our other methods, and if in case we want to resize.
I'm saying, couldn't you just call the MyArrayList default constructor instead of the MyArray?
I could call here after I resize. I could call the default constructor. Yeah, I could call this now after I rewrite the value of this. Yeah, well, that would be another option for us to do it. Basically, as your friend suggested, you could do this as well after you're done with this one. But that's fine because it's just that doesn't really matter at this point. It's not a big too much change here. We didn't take any any particular requirement at this point, so we're good. I think we can keep it that way for now. So another thing that we like to have, since we have this method size, it's good to have a method to give us the value of the size, and also that's exactly what we have in the Java as well. So this is going to give us the value of the size is going to be returned. We have a condition here to making sure that, actually that's your friend mentioned, that's a good idea. You can have a condition here to making sure that when the user enter the capacity is going to be at least bigger than 4. And so if it's less than 4, we're going to use the default capacity. So we're only going to override this if it's bigger than 4. Otherwise, we're just going to use this, regional capacity, which is 4. So because we don't want a user to enter the negative number or the, less than 4, it's going to mess up our data structure. So we're going to have that condition here. If the capacity that user enter is like less than 4, we're going to just use the default capacity, which is 4, and we already have it right here.